One of the types of steam trap is mechanical type of steam trap. The mechanical types of steam traps include ball float and bucket traps, both of which operate on the principle of density differential between the steam and the condensate. All mechanical traps work on the principle of a float operating a discharge valve to release the condensate. The examples of mechanical traps are closed ball float, open top bucket float, inverted bucket float, closed ball float steam trap. The closed ball float trap responds to the buoyancy of a level of condensate. The ball float is attached to the discharge valve by a lever. As condensate enters and accumulates in the bottom of the trap's body, the condensate level rises to a predetermined point at which the float's buoyancy forces open the discharge valve. The steam pressure then forces the condensate out through the trap's outlet. Float traps are designed to discharge condensate continuously and work best with large volumes of condensate. Normally the amount of condensate entering the trap equals the amount of condensate leaving. Because float traps do not regularly open and close, they are usually free from water hammer. However, in cold weather, float traps are susceptible to freezing because of their need for a condensate reservoir. Float traps automatically compensate for condensate load. For example, if the amount of condensate entering the trap increases, the condensate level rises. This causes the float to rise higher and further open the valve, therefore increasing the amount of condensate being discharged. The discharge valve will close completely if the amount of condensate entering the trap decreases too much. Most float traps are equipped with a thermostatic air vent which discharges non-condensable gases. This air vent works because trapped air and other non-condensable gases have lower temperatures than steam. The thermostatic air vent remains open as long as the gas temperatures in the trap's body are below the operating steam temperature. Open top bucket float. Like float traps, bucket traps also use the density differential between steam and condensate in order to function. An open-top bucket trap has an open-top upright floating bucket connected to the discharge valve system. When the bucket is at its highest position, the discharge valve is closed. As the bucket drops, the discharge valve opens. When starting up an open-top bucket trap, condensate enters at the top and is deflected downward by a baffle. As the reservoir fills, the empty bucket floats upward and closes the valve when the bucket is at its highest position. As more condensate enters the trap, the condensate overflows into the bucket. As the bucket is filled, it becomes heavier and moves downward, therefore opening the discharge valve. The line pressure pushes the condensate up and out of the trap through the discharge valve. For an example of an open-top bucket trap, refer to figure. The bucket is designed to start floating before it is completely empty. Therefore the discharge valve closes before the bucket is empty. This leaves a water seal in the bottom of the bucket which prevents the loss of steam. When the discharge valve closes, the trap is ready for another cycle. Under some conditions, the steam trap's body can become filled with air or other non-condensable gases that prevent condensate from flowing into the trap. This problem is corrected by opening a manually operated release valve to purge the trapped air and other gases. This valve must be closed after the purge is complete in order to prevent a loss of steam. Dirt and silt occasionally collect in the bottom of the bucket, increasing its weight and preventing it from operating properly. When this occurs, the bucket must be cleaned out. Also, protection against freezing is necessary in cold weather because the open-top bucket trap is not self-draining. Inverted bucket float. The upside-down or inverted bucket trap also operates on the float principle, responding to the density differential between the condensate and the steam. The discharge valve is open when the inverted bucket is down and closed when the bucket is up. Steam entering the trap causes the bucket to float upward. As the bucket floats, the discharge valve closes. Figure is an example of an inverted bucket trap. Consider the mechanics of an inverted bucket during startup. The trap is empty and the inverted bucket rests on the bottom of the trap with the discharge valve open. As the steam line is pressurized, air and condensate within the system are pushed by the steam pressure into the trap. The air passes through the bucket's small orifice and out through the discharge valve. Now, because the discharge valve is closed, steam is unable to enter the trap. The small quantity of steam in the inverted bucket